Hi again, everyone. Today we're going to look at a very simple problem from Fourier series. Okay, so we're asked to compute the Fourier series of this given function, and the function in particular is periodic with period 2. Now, Fourier series, they're just a kind of series that involve cosines and sines. Okay, and when we calculate a Fourier series, we try to determine the coefficients of those cosines and sines. So the A naughts, the ANs, and the BNs. Okay. Now, how are Fourier series useful? Well, Fourier series are an integral part of solving partial differential equations. These partial differential equations come from heat flow and, for example, the wave equation. Okay, but today's example is just simple. Calculate the Fourier series, and you do that by calculating the Fourier coefficients. Okay, so the first thing we note is that our function has period 2. All right, now we write the period, or denote the period, by 2L, okay? So in this case, L equals 1. This is important for finding our Fourier coefficients. Also note that the Fourier, the given function is odd, okay? Okay, so this isn't drawn to scale, but the Fourier coefficient, the function is an odd function. Now, why is that important? Well, to compute the Fourier coefficients, the A naughts, the ANs, and the BNs, we rely on integration. And we know that if we integrate, say, an odd function over the interval -1 to 1, things are going to simplify. Okay, so it's very important. So, the important observation is f is odd. And so, the A naught, if you look up the formula for A naught, it's just the following. So here I'm using the formula with big L equals to 1. All right, well, we don't even really need to calculate this integral because it's just the area there, which will be negative, and there, they're just going to cancel each other out. We get 0, okay? What about A sub n for n greater than or equal to 1? Well, applying the formula with big L equals 1, we want to integrate this. But look closely, f's an odd function. Cos is an even function. So we've got the integral of an odd function times an even function. An odd function times an even function gives us an odd function. So we're integrating an odd function between -1 and 1. It's got to be 0. Again, the areas cancel. So for each n greater than or equal to 0, this integral is 0. What about the b sub n? Well, b sub n is similar to this, but you replace cosine with sine. All right, so where does that take us? Well, we've got an odd function, the product is an even function. Now, if we integrate an even function between, say, -1 and 1, we can do the following. We double the integral and halve the length of integration. So instead of integrating from -1 to 1, we integrate from 0 to 1. Okay, so on this interval, 0 to 1, f of x is 3. So we replace f of x with 3 sine n pi x dx. Now 3 is just a constant, so I can take it out the front, and I want to integrate sine n pi x. So let's do that. So I'll get 6 out the front. When I integrate sine, I get minus cosine, and I've got to divide by n pi. So I'm going to bring that minus out the front, divide by n pi, and I'm going to get cos n pi x. All right, so now it's time to put in x equals 1 and x equals 0. So here I'll get cos n pi minus cos of 0, which is just 1. Okay, so what do we do now? Well, we can clean this up a bit. Cos n pi, it goes positive 1, negative 1, positive 1, negative 1. So cos n pi is actually the following. You can write it in the following way. It's an oscillating sequence. Okay. We can still go a little bit further here. If n's even, this is going to be 1 minus 1, so it's 0. If n is odd, then this is going to be minus 1 minus 1. So we can go a little bit further, and it's going to be this. 0 for n even. Then if n's odd, we get minus 2 here, minus 2 times minus 6 on n pi. 12 on n pi when n is odd. Okay, so what's our Fourier series? Well, let's go back to the formula for Fourier series. Our a0, 0. The a_n's are all 0. The bn's, well, they're 0 for n even and 12 on n pi for n odd. So let's write out our Fourier series. Now, I denote the Fourier series of little f of x by big S f of x. So a0, 0, a_n's are 0, and it's the only non-zero ones are bn for n odd. So look what I do here. I'm only adding, or I'm only putting in those n that are odd in the sum. Because otherwise, if n's even, then I'm just adding 0 together, right? So this is my Fourier series, okay? Now there's no cosines in there, it's only sines. So sometimes we refer to this as a Fourier sine series. All right.